without further ado, let's continue. We have around an hour left, which I think we can definitely complete what we need to complete. So, for practice, I'd like you to do part B of this question, where the guy now has to take the shortest route and what direction he should head. Try to do that by yourself. Very important. And a similar type question is with an aircraft, and you basically also are asking what they're requesting which direction you should head and how long it will take. All the type of questions I'm showing you here and what we've done today is all the type of questions which can be expected in terms of a test and assessment. So I'm making aware they're all particularly good, especially this practice ones, all of them. No, not maybe the first example. Second one good, but more this one or that one. That you're aware of what kind of level you're expecting. But obviously, once you see the next part, that talks to this as well. So make sure you solve these examples, and I think I'll probably do one of them in class, and then yeah, you guys just go play around with the rest. Okay. So in terms of the book alignment, I think chapter 19, the chapter is fairly small, but it adds 1 or 2 extra examples which could obviously aid you in the supplementary textbook. But mostly for this particular chapter, my notes would be my slides and extra notes tutorials would be sufficient. I did post some last year's tests which I've developed and previous exams. So chapter 17. My bad then. Are you sure chapter 17? Unless you bought the actual textbook, and that could be different. So I'm not particularly sure there. Let me just confirm it on the soft copy. It says 19 in my one, so yeah. It's not linear motion, it's relative velocity. So yeah, it's 19. Okay, cool. All right, so get your brains ready. This is what we're going to be doing now. So where we're moving on is, instead of having one object and having either a ship or a boat and there's a fluid moving and the wind, what a typical problem will typically be like is something around this nature, and you'll see how we build on the problem. So we actually go to the next section worth of work. After this, there's 2 more parts of this particular chapter, and then you'll close the chapter. So this is the second bit of it. So what they're talking about here, so they're saying that suppose you have 2 vehicles and they're differing in different paths. So one is going flat, a flat plane, and one is coming at an angle. And so suppose you want to see the velocity of B that appears to be seen from the observer A. You'd call this the velocity B relative to A. So obviously you be aware of what relative velocity is, but a lot of what we're going to be doing now is having 2 different bodies moving, whether it be a car, ship, or plane, and we want to see the velocity relative to another. Now, what's very important of the notation, and I'm making you aware now, is that when you write V subscript BA, we are saying B relative to A, because you can also find A relative to B, and which you're actually going to try and do. And we're going to see how we can apply this. So it's fairly procedural in terms of the understanding, but the understanding will kind of reveal itself through the next section. So it's all fundamental, all building blocks towards a particular piece. So in this case, you typically have 2 bodies moving, and we're going to have to analyze it. So in keeping with that too, so for us to find the velocity of B relative to A, what do we need to do? So they say, so in order to see what velocity of B appears to be from A, we have to now make vehicle BA stand still. Right, so remember VBA, velocity of B relative to A. So what we do, you apply a velocity vector in the opposite direction, right? So it's not a negative value that stays there, it's an opposite vector. So that kind of makes sense. So if we apply a vector in the opposite direction here, right? We're just saying now A is standing still, and now we can see how B will behave in terms of its motion. Similarly, we apply an opposite direction velocity vector over here, and we can now see how A is moving relative to B. So this is what we're basically going to be doing. And once we do apply the velocity vector, so what it is talking about, what you can see, there's like a page, they kind of like it's like moving the plane a bit. As you can see, they have negative A. So you can see initially A was going in a positive direction over here. Then obviously you can see now we apply negative vector A and we keep B in the same direction. Then what we see is how how B is moving with respect to A. So that's a very important concept which we'll be using throughout this typical analysis. So they're saying there is that this means that B now has a resultant velocity equal to the vector sum of its velocity on the plane and the velocity imparted on the plane vector sum of negative A. In keeping, when I do ask for definition, what is a relative velocity? And the relative velocity is essentially the vectorial difference of velocities. Very important concept, right? So it's the two vector differences of an object. So obviously the difference would be this. So in the equation form, I would write this, and this is very important because I'll definitely be giving a mark for the equation to see that you're doing it right. And there's a reason why I'm giving a mark for the equation. And this is because it's for you to understand when you're applying when you're stopping one body compared to or relative to another body. And so they're saying the resultant velocity is how the velocity of B appears from vehicle A. So remember that first thought that two cars coming together. In this case, we have cars moving in different directions. And we are seeing how one body appears to be moving relative to another. So then they say the velocity of B relative to A is the resultant of B and the opposite to and the opposite vector to A. So this can be expressed as an equation so depending what you're doing, that's how you're going to be writing out your first equation. You're going to be writing out, you're going to be applying is that you normally get 1 mark for that. So I'm making you aware. It's a very important concept when you're analyzing these problems. So say note, it's not an arithmetic equation. It's a vectorial equation. So we're analyzing vectors. So we're just saying we're applying a negative vector. So I just want to talk to that. For instance, if you are looking at, and we'll be solving a problem immediately after this. If you're looking at the velocity of A relative to B, because you can also do that, then you're going to say AV, AB, VA, and relative to B, meaning we have to put opposite vector to make B stand still to see how A is moving, right? So you might ask, Mr. Skull, what does this look like? So an idea of this is this over there. You see that plane over there? Can you guys see it? So B is standing still, and you can see how A is moving with respect to B. Are you guys happy with that? You understand what we're trying to achieve here, right? And obviously, this is another section. Do we all get that? Just make that bigger, a bit bigger. Am I still audible, students? So that's what we're trying to find. And these bodies are all moving in different directions. I guess you guys are on the same page as me. So the notation is very important. And yeah. So over here, we're going to be doing an example straight off the cuff. Very, very, very important. You need to know how to do two bodies moving at the same time, right? In this case, what they're saying, what they want here is that at a given moment, two ships near one another are proceeding on a straight course with the respective velocities shown. Determine the velocity of ship A relative to ship B. There's another example you do as a practice one. I'll show you the first approach, and then there's a few ones you can actually play around with. This was taken from a class test of last year, so you can kind of see what you're looking at. And I'll give you different variations on how these questions are basically structured. I'll probably will generate a small tutorial so you can actually play around and see how it works. Okay, so let's see the standard procedure which I'll show you, and then we'll actually yeah, you'll get to obviously play around with a few examples. So this is a very important example. It forms a basis for the next part of the chapter, which is a relative path. So it's in your best interest to take note here, right? And all we're doing is seeing how one body removes respect to another one. Okay. Is there any questions as for? Is it clear what I've said? Some thumbs up, students, if you're happy with that. Let's go into my whiteboard now. Thank you, Mr. Silver. It's you'll see. I'll show you the exam type, level type questions. But this is obviously a very important concept. Straightforward. It's just a Stoller tables, right? So what I'm going to do first is show you velocity of A relative to B, and you're going to do B relative to A, right? So how do we start this, right? So it's always typically a two-body problem, and they're moving in different directions. Sometimes I can give it in nautical miles, sometimes in knots, but I typically keep it in kilometers, and yeah, it's just easier that way. So of course this becomes very important, your notations over here, right? Make sure you get be familiar with that notation. I might give you extra mark for that. Yeah. So the question wants the velocity of A with relative to B. So how do you write it? A relative to B. This is the one stationary. You will say VA plus, open a bracket, say negative B. And you're going to see how you apply this equation. This will give you 1 mark. You can write that, at least you understood the question, right? What we need to do now is plot the Cartesian plane, right? That's what we're going to do now. Plot a Cartesian plane, yeah, on how these bodies are essentially moving, right? Okay, so I'll just draw this line, continue on. So the first body A, can you see how we're plotting it? That's A, or call it VA. Velocity of A is moving at 20 kilometers per hour at 35 degrees. Velocity of B, put it like this. Excuse me for that. At 75 degrees. Cool, right? Nice. And this will be 32 kilometers per hour. Bian, how do you think we're gonna find the velocity of A relative to B? What have you been doing the whole time? So start with components. Well done. I'm expecting 80% from this man. But what's important now, Tashariq, Mr. Asa, PJ, Amanda, remember what I said? What must we do to find the velocity of A relative to B? What do we need to do now? What do we have to apply? Remember, you're applying this formula. What do we need to do? What did I say in the slides? I'll give you guys a minute, 2 minutes to tell me. So, Sipo, how do we perceive one body moving relative to the other one? I said we have to do something. We have to apply something. Make one stand still. Yes. And what do we do? I don't know if Amanda spoke. I think the mic is muted. Make B stand still. Exactly. And what do we do is apply, I'll write it in green, an opposite vector. So we know that's V minus B. There we go. So we've actually applied that equation. And of course, that angle is adjacent to that angle over there. Once we've done this, now we can finally start our analysis. That is, now we can start finding the components. So obviously the best, what I recommend, what I like to do is open up a table. I should make my columns of equal width. Get a row in, another row, and one over here. Velocity of A, velocity of B, and then X, and then Y. All right. So I'm not going to do this. You guys will resolve the components. I want the total number here and total number here. Once again, I'll make a keynote here. Be aware of directions. Very, very important. And I'm saying this now, you can have I could give you a similar problem, just like this, where the body now is moving, one is moving this way, and the other one is moving that way. Does it make sense? Or I can say one is going like that, the other one is going like, or two is going like that. There's many variations with this problem. That's what I'm trying to create a tutorial on how to do this. So what I'm saying is B can go like this. So let's say B is going like that. And then A, for instance, will be going like that. See there? All right. Okay. So I'll give you 2 minutes. Or let me do the components for you. Then you can solve the velocity. So at VA, it's going to be 20 cos 35 positive right plus 20 sine 35 positive. Be aware of directions. Over here we have 20, sorry, not 20. What is B's velocity? 32. I should have written that there. So that's 32 cos 75 and negative, right? Negative 32 sine 75. Just make that big for you here. Are we all clear on how I found the components? Students, are we all clear on that? Straightforward. You're on your way. Thank you, Tashriq. So what I want you to do is find the resultant velocity. Right, so if you're standing from the ground, assuming that one body is standing from the other one, well, not from the ground particularly, rather from A now. But it's in keeping with the next section here. So VA will simply be obviously Vx, the sum of Vx squared plus the sum of Vy squared. That will be the magnitude. A relative to B. All right, let's see. Okay, so I'll just give you guys a moment. The answer is there, and hopefully you will get it. So take around 5 minutes to get that and the angle. Very important concept. You can do this, you've at least got, for this type question, 8 marks, roughly 8 marks of the question. And the other marks are around another 8 marks basically. This is the core concept Nice, Muda. Is it Mr. Muda or Mrs. Muda? Miss Muda. Nice. Okay, one more minute. Guys, for this particular chapter, focus on the slides and the tutorials I post. The textbook can be a bit daunting with the notepad. Fantastic for you, Joe. But you'll get the gist of what's expected of you. Um, okay, so let's quickly just solve this. Um, all right, so let's quickly see. 20 cos 35 plus 32 cos 75. Should get 24.66, or rather 67. Don't know why I'm writing so messy here, man. So it's 24.67. And then we have 20 sine 35 minus 32 sine 75. Get minus 19.438. And if you find the sum, the vector sum here, 24.67, I'm not getting my answer here. Where did I mess up? So it's 20 cos 35. What answer do you guys get? 32 cos 75, 24.67, 20. Yeah, I don't know. We have made a mistake. 20 sine 35 minus 32 sine 75. It's probably there. Minus 19.3. Yeah, that's right. So let me just quickly see. Squared plus 24.67 squared. Yeah, 31.4. Oh, my bad. I have a 31.4. Yeah. Well, x components 29.3. Oh, yeah. I get rounded off a bit. So I got 31.407. Good enough. Okay. Or roughly on the same track over there. Okay. And then that's 407. What is next? Obviously direction, and it's always going to be your y over your x. And this is very important. You got to keep your signs. So it's 19,438 over 24.67. Very, very important. Keep that sign there, and you'll see why. Excuse me. Oh, I just got a sneeze here. Yeah. 24.67. And what angle do I get? Is my angle right there? What angle did you guys get? 19.438 and 24.67 minus 38,235 degrees. Right, so we'll talk about what this means. Very, very important. Okay, so what that means, guys, so I'll just sketch everything here. We've got that line. We've got VA. We've got negative VB. Negative V is that is at 75 degrees, right? So that's a bit more like that. So negative VB got VA. And what it means is that a negative angle, remember, so clock, we typically go this way for positive. So we know that this guy is at 38 degrees going this way. So it's 38.235. I might ask you to sketch this, so be aware. So again, I have supposed to be like a parallelogram obviously over here with correct vector sizes, but obviously it's a bit tricky in this case. It's not to scale. But what it means is that from B, A is going just get our notations in here. How's A going? East of south. It's going east or south. So if you make B stand still, which is B is essentially standing still over here, I think, A will be, it looks like A is moving basically that way at the 6.235. Typical mark allocations for this, you probably get a mark here, 2 marks here, 2 marks there. So it's 1, 2, 3, 4, 5, 6, 7, around 7 marks for a question like this already. Right, we'll see if you look at the test how it's been done.
Sorry, sir.
Go
Sorry.
for it.
Yes, the angle is 38, not 36.
Hey, my bad. Yeah, sorry about that. 38. Yeah, it's just making aware. So let's this time is running out here because I know I just posted an announcement on WhatsApp of Mr. Levita's class. That's fine. So now let's try V. Let's do B relative to A now. So we're gonna be doing, we want B relative to A. You guys get that? So we're gonna do B relative to A. Yeah, I've just to B relative to A, to the relative velocity. Oh, toric is Sorry about that. My computer just gave me a slight freeze there. Just go back to the whiteboard. Okay. So what we're doing now is B relative to A. Okay. Is everyone still there? I think we'll call it after today. I mean, after this example. And obviously, I'll just direct it some practice and create some more practice. Okay, so we're applying B relative to A. That's going to be VA plus negative B now. Remember, the notation is very, very important. Right, very, very important. So B will remain the same. So B is going this way, right? That's a 75 degrees, and A will be going. So now A was initially going that way, but obviously we have to now we are stopping. We're stopping A now. So A is stopping A. So A is going to be here. A was initially there at 35 degrees. So this will become minus VA. Very important, guys. VB. So I can erase that. So can you see the difference is the quadrants where the depending how it's going to move. Students, are you still there? Fantastic. So I'm just showing you the difference here. Thank you, Vian. Let's quickly just do this. So VB was 32 kilometers per hour, and then VA was 20, right? So we go. Now we know that that's going to be negative. I'll start with B. Well, I can start with A rather. It's minus 20 cos 35, and then minus 32 cos 75. That'll give me an answer. I can just move this. Furthermore, sum of Vy, that's going to be starting with A, so it's minus 20 sine 35 plus 32, right? 32 sine 75. Be aware of the directions. Remember, X is negative in this quadrant, positive, positive, negative, negative. Yes, Ms. Panke.
Sir, can you please explain which one should be stopped, or does it matter? And
yes,
also,
yes, it does matter.
And okay, so can you please first explain like which one exactly should be stopped?
So in this first question, I said determine the velocity of A relative to B, right? So when you write it down, so you're going to say VAB, and this is the one you stop. The second subscript, that's what I said.
Okay.
Then we have to apply the vector there. So what I'm saying on the second part, which I just created now, is we're stopping A now instead. See, so A was initially here at 35 degrees. So now we're stopping A over there. Do you see? So I think I made a mistake here, yeah. Just asking confusion. V stopping A. Did I answer your question, Ms. Panji?
Yes, kind of. And also, with these kind of examples, do we always have like two vectors, or could we find more than one vector at a given time? Like, say, for instance, more than two components.
Yeah, it's always two components. There is an example with like we have three components, but it's like relative to the wind. It's you'll see it, man. But it's always maximum two components.
Okay.
Yeah.
All right.
You see the slides. You'll attempt that one. You let me know. Yeah.
All right.
Okay.
Thank you.
You'll see, but it's always two. Don't worry. Yeah. 100%. So I'm just making sure you got the directions there. That's very important because otherwise you'll be wrong. I cannot mark you right if you miss up your directions. So that's minus 24.665, right, meters per second. The second one is minus 20 sine 35 plus 32 sine 75. That's 19.438 meters per second. And obviously now we can find the resultant vector, which is VBA. And that's going to be obviously the sum of Vx squared plus the sum of Vy squared. All right, so we can do that. And let's see what we get. Should get exactly the same answer, 31.40385 meters per second. That's definitely what's gonna happen. Fantastic. But the only difference is because now we're stopping A, our direction will be different. Right? Our direction will be different. Right, so we know it's always y over x, so it's 19.438. That is why quadrants are important. It's minus 24.665. What do we get here? Directions are confusing. Yeah, it can be. Let me just see here. 19.438. 24.665. Angles what? 38.24. Yes. That's fine. That was one more. That's probably old hand. Who's that? Buddha. Miss Buddha.
Hi, sir.
Go for it.
Ooh, I can't go further. I'm stuck at the part where I have to. It's with the directions. There.
Yes. I'm listening.
Yes. Since the VA, the minus VA, is now at
Yes.
the which quadrant is that? The negative side,
That's
right?
third. Yeah, the third quadrant here.
Yes. But I'm confused now with the directions.
Let
With
me
okay,
see.
when I'm putting my x's and y's there,
Yes.
before I even come to calculate with the what's the table, I'm
Yeah.
using the table. I find it much more easier.
Yeah, it's fine. Yeah.
Yes, so I can't seem to figure out because I see on the VB there's a part that it goes up, right? And then it
Okay, cool.
becomes a positive. Yes, that's where it's confusing.
Oh, cool. Nice. Okay. I'm actually a bit concerned with my other value here, but anyway, we'll have to figure that out. Oh, but anyway, I think I know what it is. Anyway, so going back to the directions, right? So to split, I'm gonna split each one of the components for you so you can actually just see. So let's just first do VB, right? So VB is like this at 75 degrees, right? Bear with me. That's VB. And what we're going to do is split that one. So that's going to be, what is VB's value again? It was 32, right? So that's 32 cos 75. And split the other one, and that's going to be 32 sine 75. Are you happy about that? You got that?
Yes, I'm happy.
Okay, nice. So anything to the right basically is positive. Anything going up is positive. Anything going to the left is negative, and anything going down is considered negative. So that's going to be a plus. That's going to be a negative. You got that? That's how the directions work. Maybe just
Yes,
forget.
yes, I got that
Yeah.
part, sir. Yes, I got that
Okay,
part.
cool.
So, sir,
Okay.
okay. What if at some point I got confused and I decided that that arrow now is going down? Is it
Which arrow? This one?
the positive one going up?
Yes. It will throw out your values. Like the way I know be correct here is by your relative velocity of VBA and VAB should be exactly the same. When you see the 34,407, 34,438, it should be close. That's one thing. That's how we know we're right here. It will throw out that value, basically, because you'll be adding. And there's another way to kind of know, which I'm trying to like show you the direction as well. And obviously, if you're stopping B, for instance, over here, you can roughly imagine how this will actually, it'll go like that, which I've tried to demonstrate over there. So yeah, you won't if you just know. Like for instance, I'll do the next velocity vector, which is, I'm assuming I got the angles right here. So if that angle was there at A, let me just make sure it was there at A. The other one should be here, right? Okay, so I can just erase this. It's good these questions are coming up. And this is V, what's this now? VA, right? So this one in components, that is going to be 20, obviously VA, cos 35, and that's also negative, right? As you can see there. And obviously this one is going down like that. So that's going to be 20 sine 35 negative. Ms. Mura, did you get that? It's you have to just, when you split in the components, I think that's probably where people are rusty, is that if you split a component like that, it's always going to be one here and one there.
Okay, I get you, sir. Thank you.
Yeah, and if you have a component facing a point, the component to be like that or like that. So yeah, that's basically the thing. Yeah. So it's always going outwards. Because if you take the resultant of these two guys, the 20 cos 35 plus minus 20 cos 35, you exactly get the 20. If you take the resultant, that's what essentially is happening here. Okay, cool. So is our angle, what angle did we get? The directions are confusing. Yeah, it's fine. I hope that cleared some answers. So do you guys agree with my angle as well? I'm hoping I'm right with my angles here because it's a bit of a problem. Yes. Yeah, there we go, Ms. Mom. Just talking some other stuff now. So what angle did I get? So now I got this is negative now, right? That's the actual answer there. But it's not so simple. It's west of north. There we go. This is what I'm talking about. So now that's there. That's north. West of north. So we always saying this angle is. So let's be clear here. Where is that velocity? You're saying west of north is at the bottom here. Yeah. Oh, west of, yeah, west going to north. No, that's on top. So where is this velocity vector? Is it west of north or south of west? South of west. That's what I say. I'm saying it's south of west, guys. Rian, why do you say west of north? Maybe I'm missing something. It's always tricky with these values.
Sir, isn't it
Yeah,
because is it not because you're working from the horizontal plane going west that gives you your negative, and then you've got a positive degree going northwards?
Yeah, so remember positive is negative down here, right?
Yes, but wouldn't that give you a double negative because south and west are both negative?
I see a double negative. So you're saying it's going up here. So positive and negative is going to give you a like that there. Are you saying west of north? That's a good point. Just give me a moment. Directions are always getting me as well, so don't worry. Just give me one slight moment. With the angle, because remember we're measuring from the other side now. I just want to see something on my on the one example, south of north of west, north of west. I think it's yeah, north. I can agree with Vian for now. Because this is where it becomes a bit tricky now over here, especially when dealing on the other side of the angle, on the other side of the Cartesian plane. Yes, Mr. Silver, I'd like to hear your thoughts. Still speaking. Yeah, so north of that, north of west, yeah, so that means it's what I feel. I agree with that. So it's basically that 51 there. That's basically what it's there's two of them there, right? You could either have it as west of north 38. I'd like to hear why. 28 point, was it 32? Is it 32 point, 38.24? That's a tricky part of this. 38.24 west of north, or you can have north of east. What's 90, which is 51? 90 minus that angle. 90 minus 38.24. Fortunately, the direction is only like worth, this will be probably extra mark. So I agree with that. Mic not working. Okay. Mr. Mabisa, why do you go for that answer? Please explain more. Yeah. I personally feel that one is right. I just think when we're measuring the angles on the other side, we have to go the other way. But then also the mathematical sense of being a double negative makes it a positive is quite interesting actually. So I think when you're on that side, when you're on the right hand side of the Cartesian plane, or the left hand side, you have to go back up. I'm very confused now. No, for sure. Don't worry. It is confusing.
So, excuse me.
Go for it. Yeah.
Yes, shouldn't be a west 35 or 38.24 south instead of west.
You say like this, right? Exactly. Right? That's what we're saying. Am I right? That's what I also think the answer is. But you're saying that's the answer, right? In that direction.
But how come so?
So we must just remember how we're measuring these angles over here, right? I think that's what's important. That's why I'm asking. Vian says is a double negative because I can accept either one, right? It becomes a bit tricky, right? They're both 38.24, but we just don't know place in which quadrant it actually is now. That's what's important. So I want to hear some visas because there's always a debate of mine every semester. So it's perfectly fine. So I want to hear what she has to say. So I agree. I mean, the idea is that it's negative, but what Vian is saying is that if you know this quadrant here, that's positive and negative, right? That's why that makes sense. These angles here are positive and negative. But in this case, if you look at this here, you have a negative and a negative, and this would have been positive. So that is why it's just solely based on that two values over here. If you split the resultant's components, you're gonna find that it must be a negative and a positive. That is why I agree with that. It works opposite on the other side.
Yeah, because for the
unless you prove me wrong.
Yeah, for the second one, sir. Yeah, for the second one, we can say yes. I think so. But for the first one, I think the direction we have to double check it.
The first one.
No,
East of
I
south.
said the second one. Yeah, the second one is right.
This one.
Because we have the right angles, minus the angle that we got from the tangent. So, but for the first one, we have to take it again.
I'm not sure which, but anyway, the point.
That one west 38 north is what I'm talking about. But the bottom one, yeah.
Oh, that's the same. That's the same thing. That represents the same thing. Remember, that's north of west and west of north. It's the same thing. Just depending where you're choosing from. And I agree with VR. VR just exactly.
Yes.
Go ahead, VR.
Sir, also, if you look at your table that you worked out, you've got the resulting velocities on your two vectors, or on your x and your y-axis. So on your y-axis, you have a positive result of 19.438, but on your x, you have a negative of 24.
Negative.
So your y-axis must be north because it's a positive. And then
that's correct. I agree. That's why I'm saying you're right. 100%. I'm being honest. 100%. Mr. Mambisa, so they're definitely right. We finally figured that one out now. Thanks. Unless you were, yeah, we sorted that out. I'll repeat that now. Your mic not working. That is a good exercise. Mr. Mambisa, I'm waiting on you. If you refer to so let's see what it makes sense. So we refer to the sum of the components, and therefore we can judge that that's positive, that's negative. It should be in that quadrant. That makes perfect sense. That's how we know. And if we use the same idea here, one is positive, the x is positive, and the y is negative. So that makes perfect sense if you have a look here. So x is positive and y is negative, and that's perfect. That actually makes more sense, I guess, versus me saying kind of measure the angles the other way. Back to, I think, Antonio, what we're saying is that 38 from west of north is exactly the same from north to, I think it's the same thing. We can actually say from west to north, but I will accept both these answers. I think they mean the same thing to me.
Okay, I got it.
Okay, great. Okay, guys, thank you for that fantastic session. And let's see, we're still waiting for you to speak. But Vian has elucidated exactly, so we exactly know which direction where the body will be. So I've posted some stuff on Blackboard. I'm posting the slides up as well, and I'm gonna thank you guys for all the energy today and response. So at least we know exactly where our body will be. Okay, it's fine. But yeah, you and Mr. Vian got it right. So guys, appreciate it. Anyway, I'll see you next week, probably on campus, where we'll continue and conclude relative velocity. And I will be posting. Thank you, Tashrik. I hope you enjoyed it. I will post. I'm making a new exercise with these kind of examples with different arrows pointing different ways, and you can kind of practice exactly where everything is. But next week we continue with the relative path and interception, and then we're done with the chapter. So make sure you keep on practicing, keep the momentum going. Test dates will be communicated to you probably by next week. I just have to just confirm. You might write off the holiday. I'm planning, but anyway, I'm just dropping that for now. But anyway, guys, see you and have a good day further. Cheers. And